So, welcome to my next Kerbal Space Program video using the KOS mod. This one's long, I'll warn you. You might want to take a quick glance down at the total video duration before you commit yourself. In this video, I did a mission to Duna and its moon Ike, and then back home. It's a bit crude, but if I get it submitted on time, it will be the first entry into the challenge contest that contains an actual interplanetary transfer, instead of just like going to a moon. Okay, so to recap what these videos are about, there's this rather nifty mod for KSP called Kerbal Operating System, or just KOS. It's a mod that lets you put a little computer part on your ship and then have it run programs you write to control the ship in a little scripting language. It's an alternative to using the autopilot of the MechJeb mod, where all the fun has, in my opinion, been sucked out of it. Because all the programming has already been done for you, and it's already hard-coded to just work out of the box without any player agency on your part. So anyway, this is my second entry into the KOS Automated Mission Challenge. I'll leave a link to the forum post where the challenge was issued down in the video description when I'm done. But the basic summary of the challenge is that using KOS, you have to succeed in completing a remote robotic mission entirely only with KOS scripts and KOS terminal commands. The idea is to simulate the problem that in a real probe mission, the delay caused by the speed of light makes it impossible to get live remote control of the craft. You can issue script commands to the craft, but only if they work with long delays, not if they require instant feedback to work. There are some specific rules of the challenge, and instead of reading them out, I'll just leave them on this intro screen for you to read if you want to. If you want to read them, pause the video here and read them through. Otherwise, just wait a few seconds, and then we'll start in. In order to keep myself honest about that whole light speed radio delay thing, I made this little script in Kerbal Script that I use every time I want to send a new command to the craft. It's called sim radio delay, and what it does is I can send it any command I feel like, any sort of string command that I want, up there at the top where it says declare parameter RD command. And then what it will do is it will take a look at the light speed, or speed of light, and a little extra padding and how much distance I have to Kerbin. And based upon all of that, it will sit down and delay for a little while, depending on how far I am from Kerbin and how long light speed delay is. It actually takes twice as long as it should on purpose, because I'm assuming a round trip exists, plus a little bit of extra padding seconds. And then it'll print out this little block and show you the fact that the delay is counting down. And it won't do the command you said until the delay is over. And I do this to keep myself honest so that I won't do anything that requires immediate feedback. And then it does use a little bit of self-modifying code down here at the bottom to run the remote command that you gave it. And then every time I use that sim radio delay, I use it from this master script called Challenge Mission 2. The first step it will do will be to run a thing called load ascend, which just puts a couple of files on the tiny remote drive, run the ascend program, and then unload it with the unload ascend program. And basically that's the model used at every one of these steps. A thing that loads all the software, run the software, a thing that removes the software. And the steps are numbered 0 through 17 for the mission. So the first bit was ascending from Kerbin, the second bit is going to be to escape from Kerbin's sphere of influence, the next bit's going to be to transfer to Duna, and then we're going to go on to all these other steps further on down. I think I'm not going to actually go over all of these right now. I'm just going to skip now to the part where we actually run this. But this is just to give you a vague idea of what the master script you're going to be seeing is actually doing. Okay, the original audio that I made for this, when I first narrated as I was playing, didn't quite come through very well, so now what I'm doing is my voice you're hearing now is going to be me narrating after the fact as I watch myself do the video. So here we start, I switch to 0, I run the Challenge Mission 2, giving it a parameter of 0, which means the first step. It has some delays in there, or it has a little bit of extra 3-second delay for my radio script. And we got to wait a little bit to get everything loaded on. And then when it runs, we'll have a takeoff very shortly here. Incidentally, you may hear in the background the sound of a TV. I was watching TV when I first recorded this, and rather than get rid of it, I decided to just go ahead and leave it in for a little bit of flavor. It was on some late night bad 50s B-movie marathon, so you might hear an occasional weird thing in the background. It seems kind of appropriate, so I left it there. Okay, here we are in the countdown, and taking off. Now, one thing that you'll notice about this is that the animation will seem particularly clunky in certain stages, especially here at the beginning when I have a high part count. Just rest assured that to a certain extent that's the effect of the fact that I was running video recording software at the time I was doing it. My computer's not the best in the world. It's about a 2010 Mac laptop that's actually running Windows instead of OS X, but it's not the greatest gaming computer in the world. But to a large extent, the reason this is so slow in the animation rate is because the screen recorder that I was running at the time, in order to save space, because I knew this was going to be really long, I decided not to record it in RAW mode. I recorded it encoding as it went, so that it ate up some CPU time and clogged my system down a bit. But for the most part, everything still worked. Okay, as you can see where the mouse is pointing at now, I've got a bunch of stuff going on in my display up above. And one of the things that's in my new version of the script I'm using is that I can properly do asparagus or onion staging. Every time I stage, it'll print last stage reason was such and such, and there's 3 possible reasons, and those 3 Boolean values you're seeing are telling you which of the reasons it was. The first possible reason it might stage is that I have a parameter that I put in ahead of time that says just deliberately stage a few times before you take off. That's something mostly used for like a lander on the moon, where I might want to leave the bottom part behind on purpose. The second reason that it might stage is because I'm running out to 0 fuel. And then the third reason is the asparagus reason. And the way that works... asparagus again. Anyway, the reason that works is I'm watching the rate at which fuel is being burned in this box up here. And I'm comparing that to see if it suddenly changes by a significant amount between iterations. I expect it to fluctuate slightly, but if the rate at which it burns changes by a lot, unexplainedly, I make the assumption that the reason the rate changed is because one of the engines or more became starved of fuel, and therefore it's time to hit the next asparagus stage. The fuel rate is measured in terms of how many fuel units am I losing per second per kilonewton that I would expect to have of thrust if all the engines were actually thrusting. If all the engines were working, I compare that to the throttle setting and the max thrust and figure out how much kilonewtons that should be. And of course, when one of the engines gets starved of fuel, it'll suddenly drop and that won't be right anymore, which is actually what the script is detecting. So it seems to work okay for asparagus staging. I suspect that if I try using it on a large variety of engines, it might not be quite so universal because different ISPs will cause a different fuel rate change when they drop out. But it seems to have worked for both Rockomax and Skipper. I'm sorry, Rockomax is the company. It seems to have worked for both mainsail and Skipper engines. I haven't really tried it for anything that's lesser than that. But at any rate, the asparagus working was necessary for this project because in order to get to Duna and back, I'm going to need quite a hefty thing when I can't dock, and therefore I can't do it Apollo style. I can't land on the planet, come back up, redock with my fuel supply, and use it to go somewhere else. So I have to bring all the fuel that I'm going to need down to the planet and then back up again, so that necessitates a rather inefficient design. Hence, it's pretty big and hefty, and I need a pretty good lifter, thus the asparagus stage. Let's see, how is this doing here? A couple of other things to point out up there in that little window is I tell it what altitude I would like to eventually get for periapsis, and it calculates out what the velocity would be at that altitude if I was circularized at that point, and it uses that to decide how to shape the angle of aim. Basically, if you imagine drawing a square root function that starts at 0 on the ground and then ends at that preferred end speed at the top, and then imagine that the ship follows a curve that looks a bit like that. That's what I'm doing to choose the steering. It's not exactly correct for a gravity turn, but it's kind of close, so I think it works okay. Now, one effect of my re-encoding of this software into a video recorder seems to be that I appear to have cut the top of the screen off slightly, but I guess that's okay. It won't harm anything too badly. So let's see, where are we so far? Current speed is 1321, and that's pretty good. The other thing that this does is it checks the atmosphere and uses a calculation of the terminal velocity to decide whether or not it can stop burning. When it hits the point where the terminal velocity is 6 times larger than the current speed, and it's gotten the apoapsis up to the desired amount, which in this case is 80 kilometers, then it'll go ahead and stop and drift. It won't drift if the air is still too thick, because it'll assume that you'll end up dragging down and you won't quite hit that altitude after all. This part's a little slow, but that's okay. The ascent is very important. And this is after several redesigns of the craft to try to get it to the point where it uses up the last of the final stage just as it gets up there. So here we are on the map view, and you can see the apoapsis has gotten up to 80K, which is why the engines have shut themselves off. I'm not quite out of the atmosphere yet, but I'm getting close. Okay. And it's just a matter of waiting here. I don't really have much to say. So you see the top of the thing there, it says wait 95 seconds. That's how long it's going to wait until it gets to the top of the profile to try to circularize. In this particular mission, I do a lot more circularizing than I did before. It used to be the case that I wouldn't care if it's elliptical in the orbit, just as long as it's stable. But here I circularize a lot more because it's difficult to get proper predictions from a highly elliptical orbit when you only know the math for how to do circular orbit predictions. So to a certain extent, I circularize my orbits mostly just to keep the math easier, rather than because it's actually the right efficient thing to do. Some people have been writing scripts that do time warping automatically in the code. I kind of consider time warping to be a breaking the fourth wall. It's sort of a fact of the boredom of the user rather than something that actually exists in the simulation world. So I tend to not time warp in the code. I time warp manually when I'm watching it. Though there are one or two exceptions to that. I never start time warp in the code, but there are a couple of places here and there where I have sentinel checks to stop time warp. If you happen to be time warping, it'll cut it down to 1 at certain points where I really don't want it to, push past the bit where it's about to do a thing. But it never turns a time warp on. That's completely up to you. So there it's done. I'm going to take a screenshot here with my pointer on the periapsis to prove that this is in fact a stable orbit. One of the things I have to do for the challenge, I have to turn that in. Okay, so where are we? Step finished. Press AG9 to continue, Action Group 9 or Alt 9, which is my standard way in the script of starting the next step. And there's more radio delay as it loads the next piece, which is called Escape. Escape is the program that will leave Sphere of Influence, and it can either leave it in the prograde or retrograde direction. Because I'm trying to go to Duna, I would like to leave in the prograde direction of Kerbal, like that right over there, rather than the retrograde direction. The script can handle either way, but I have to tell it which I wanted. I basically tell it, am I currently in a prograde or retrograde orbit, and then I tell it what I like to burn in the prograde or retrograde direction from Kerbal. And I'm either going to make a really long ellipse going one way, or a really long ellipse going the other way, either burning on the front end or the back end of the planet. And the way I detect whether I'm at the front or the back end is I check my position relative to the planet's parent, which in this case is the sun. Although it's not hard-coded to be the sun, so the same script works on moons as well. But anyway, I look at the parent, which is the sun, and I look at my current velocity. And if I'm on the back side of the planet, the current velocity will be pointing directly away from the sun, or parent. And if I'm on the front side of the planet, my current velocity will be pointing directly toward the sun. And that's how I figure out which position of the planet I'm on. And I don't really have coordinates of the planet very easily worked out, but I do know my velocity. I do know the position of the sun relative to me. And the way to work out whether I'm pointed directly at it is, of course, to use the dot product trick. I take the two vectors, dot product them together, and then divide their magnitude out to get the cosine of the angle between them. So if I'm pointing directly away, that cosine of that angle should be -1. If I'm pointing directly toward, the cosine of that angle should be +1. And I'm waiting until it gets down to -1 or +1 to do my burn. Except I can't quite wait for it to get exactly -1 or exactly +1, because I may be in a highly inclined orbit. And if I was in a highly inclined orbit, I'm never going to be in a position where I'm pointed absolutely directly, exactly away. So what I'm actually looking for is, where is the point at which I hit a minimum, or where do I hit a maximum? And that's why I'm checking, if you see up on the little window there, for the change in cosine. I'm looking for it hits a minimum or maximum rather than for it hits exactly 1. It's important not to time warp past this point, because this is a very enormous lumbering ship and it takes it really long to get rotated around. I need to make sure I give it time to do that. It won't be quite so lumbering and slow once I drop the ascent stage. Once I burn that up and go to the smaller piece, it'll respond much nicer. But it should be getting pretty close here. Notice that cosine toward parent is currently at 0.995. When that gets to 0.99999 and then flips to the other direction, that'll be really funny. You can sort of see it in the camera here that I'm pointed directly away from the sun. We're really close to it. When that gets right spot on, it will finally fire the engines. This is probably slightly less than perfectly ideal, but again, this is just, I managed to get it to work at all, and I'm happy about that for now. Come on. Any moment now. And is it gonna finally... Ah, there we go. And it says up there in the window, burning until escape path, or burning until on escape path. And I've used up the last of that stage, and to my interplanetary nuclear stage. Yep, I'm a bad solar system citizen. I'm just littering everywhere with my spent debris stages and not crashing them down to re-entry. Terrible, terrible bad interplanetary citizen. This upper part of the ship can tolerate a 4x physics warp, so I will use that for some of these transfers, and you can see here that it's slowly burning up. I will probably come back and cut this section of the video out so you don't have to sit here and watch it slowly get bigger. And there, I cut out about a minute of slow, boring burning there. And you can see it at the point where I'm about to stretch out my ellipse to the point where it'll get out of the atmosphere. Pretty soon it'll go out. Yep, there it goes out. And in a little bit, my script will finally realize. Yep, there it goes. Coasting until leaving Kerbin's sphere of influence. The reason my code doesn't realize that I was out of the influence is because that's actually not queryable in KOS yet at the moment. You can't figure out what the sphere of influence radius of a particular body is. And so what I do is I calculate, am I well beyond escape velocity to try to decide if I'm escaped. And similarly, I kind of do an opposite thing when I try to get captured. I have to ask, am I well below terminal, or am I well below escape velocity, to try to determine if I'm captured, because I can't see if I'm within the sphere of influence or not. There's a couple of places where the behavior will be a little bit wonky because of that. That'll come up later in the mission. Okay, the bit that it's loading now is called transfer, so it's loading that on. And this is kind of the ugly part. What transfer is going to do is try to find the appropriate location to perform a transfer burn to get up to my target, which in this case is Duna. The ugly part about this is you'll notice my orbit is not perfectly circular, and Duna's orbit is also not perfectly circular. If you perform a Hohmann transfer calculation, it's assuming that the starting and ending orbits are circles. When they are not, the math to pull it off is very hard, in the sense that you can't really do direct calculus. You end up having to do integration by slices to figure things out. And the KOS computer is certainly not going to work to try and do that with. It's too slow. So what I did instead is an algorithm, which in this case actually worked fairly well, but I've seen it take many, many minutes before, where I pick the point that would be the right spot, and I pick the delta V that would be the right delta V had all the orbits been circular. And I take that as my first guess. Then what I do is I try different delta V's that are stronger or weaker, and see if any of those perform a hit. And if they don't, then I move the point further into the future and try it there. And if nothing works there, I move it further into the past and try it there. And if it doesn't work there, I move it further into the future and try it there. And I sort of iteratively keep getting further and further away from the initial guess, both in the positive and negative direction, until it finally gets a hit. It's not a very pleasant thing to sit and watch, and I'm very lucky in this case that it worked on the first hit. It normally takes a good 5 or 10 minutes of just sitting there watching it play with it for a while. Part of the reason that it takes that long is when I'm not at an encounter and I just have that little chevron that says closest approach, that I can't read that in the current version of KOS. I can't tell that I'm on a close approach, and therefore I can't use an algorithm that says, am I hotter or am I colder, am I getting closer, am I getting farther away? I can't really do that because I can't see that information. So maybe in a future version it'll get better. But at the moment, this is how I had to do it. Okay, here I am starting the burn. And if you look up in the little window, you'll notice I got rid of the maneuver node, and now I made a new one. The only reason for the maneuver node was to let the person watching the screen be able to see when the maneuver was coming. The script itself doesn't use it once it makes it. What I do instead is I create a maneuver node at 0 delta V 1 minute into the future, use it to check to see if I have an encounter, and then if I don't, I immediately remove the node, wait a little bit, and then do it again. So you're going to see these maneuver nodes appearing and disappearing as I make my burn. And the reason I have to do that is because KOS can detect when your maneuver node will cause an encounter with a planet, but it can't detect at the moment when you're already on an encounter for a planet with a maneuver node. So I need to create the maneuver nodes just for a brief moment to use them to query the system and say, are you on an encounter yet? Right now they get created very infrequently. You can see it's about once every 2 seconds or so it tries to make a new one. As I get closer to the expected final delta V, I'll be making those a lot more quickly. If you look up in the window, it says total guessed DV needed, and then DV so far this burn. When DV so far this burn starts getting close, I speed up the rate at which I check the maneuver nodes, and I also slow down the throttle. You'll see it start dropping in a moment. Yep, there it goes. So I slow the throttle down when I start getting close. And I increase the rate at which maneuver nodes are being created so that I can see when that encounter comes. I see it, there it is, and I will continue burning until I notice that the numbers aren't getting any smaller for periapsis, which in this case happened immediately. It stopped right away. This is an artifact of the fact I've got video recorder software going, because I found out that what happens is that the existence of the video recording software slows the CPU down, which causes my code to execute more slowly, and it seems to be erasing.
That wouldn't be a 2, because a 2 would be on the top.
Ignore that place there. It makes it. How do I put this? If you look at when I hover my mouse over the periapsis, you'll see that the number wiggled up and down quite a lot, and that's just the normal thing KSP does all the time. The problem is that wiggling makes it so that I will get false positives on trying to detect whether or not the periapsis is getting smaller or larger. I'll get false positives thinking I've hit a minimum when I haven't. And it turns out that the solution to that is to take an average of several samples of it to try to get that down a little bit. But the problem when I do that is that then becomes sensitive to the rate at which the CPU is running. And now that I ran this with the recorder turned on, it changed the CPU rate and caused that problem to come up when it didn't come up when I ran it without the recorder. So it's still a little bit wonky at this point. So I'm going to get an approach where I'm really far off. I'm barely going to get anywhere near the sphere of influence. I'll get into it, but only just barely, because the code that tries to get it closer got a false positive from the wiggly number into thinking it had hit the minimum already. And here I'm trying to do halfway to the target a burn where it'll either go normal or anti-normal to try to correct a little bit more. And if I remember correctly from when I made the video, that also had the same problem, where the wiggly periapsis number made it quit really early, and it only made a tiny little change, which is unfortunate. I don't quite know how to fix that, but I did manage to get the mission done anyway, partly because this thing has an abundant amount of fuel, and so I could put up with it. So there I am turning anti-normal. You can see that on that screen. And once it finally gets there, it's going to burn and try to get that periapsis closer, but it just burned for a second and stopped because the wiggly number, again, made it think that it couldn't make it any better. Or to put it another way, it's checking for when does the periapsis stop getting smaller and start getting larger again. And the fact that the number is wiggling so much makes it keep seeing all these peaks and troughs in that graph when those are kind of fake. If anyone watching this has a solution to that problem, I'd love to hear it. I'm not sure what it is. Okay, so here we are, getting near the end of that bit. You noticed I skipped a bit of the video there. So here I have a pass that's really far off. You can see that I'm nowhere near a good approach to Duna. Now it's running the capture program, which is going to try to correct that as best it can. If you look on the screen here as I rotate the viewer around, you can see where the mouse pointer is right now, a little speck. That little red speck is Duna. Well, where it was a second ago anyway. And what it's doing is it's trying to aim itself in the radial in direction to pull that blue line so that the periapsis will get right next to Duna. I'm telling it in the parameters that I gave the program that I would like to get it to, I believe the number I picked was 70 kilometers. I'm always a little nervous when I run this about the position of the moons that might get in the way. Like, it doesn't have the ability to detect whether or not Ike is going to interfere with this approach. They just get lucky enough that it doesn't. Okay, now the second thing it'll do here is burn either normal or anti-normal to try to bring me as close as possible to an equatorial hit. You'll see that that blue line is ever so slightly going upward just a bit. And now it stopped. And now, if you look at my periapsis, it went down a few thousand meters because I burned straight down from where I was. So now it'll bend outward and push it back out again to get it back up to 70, like I asked it to. So this is how my capture script works. Get closer on whatever direction you're currently off, then move straight up or down to get it equatorial, then move out a little bit to get where it was. And there are parameters you can give that script to tell it to not do some of that stuff. If you don't particularly care about it being equatorial, you don't have it to have it be equatorial. I prefer it because it makes everything more predictable in the rest of the program. So now as I get in closer, you'll see that it says in the window, waiting until 1.23.6 seconds before periapsis, because that's half the total burn time it's predicting it thinks it'll need based on the engines that it currently has. Because it's using the atomic engines, which are, pretty low powered but incredibly efficient fuel burning. And you'll notice I had 4 of them on the craft, which is, I know that's inefficient and you're better off just using 1 and having slow burns, but I'm being impatient, so I put 4 on. So any moment now, it should start in when I time warp it to the right point. Let's see, 1.29 seconds, I should say. Should be 2 minutes and 9 seconds. So when I'm 2 minutes and 9 seconds before periapsis should kick in. By the way, if you run this yourself, be very careful about the time warping here. If you time warp past the point of the burn start, your timing on the burn will be completely wrong, and you'll end up with an orbit that isn't really going to circularize correctly, and you'll end up probably on an orbit that has an intercept through the surface of the planet. So if you're going to time warp past this part, be very careful not to overdo it. Make sure that you stop before you get to the point where it says it's going to burn. Okay, there it goes. Burn starting. Also, another thing you may have noticed watching this video is that the resolution seems kind of wonky. Like the picture of the planet Duna has this fuzzy texture to it. That fuzzy texture is not what the game naturally looks like when I play it. It's looking like that at the moment, again, as an artifact of the screen recorder. As you can see, it's getting close to running out of the fuel, and it will automatically stage as it does so, even though I haven't finished my capture burn. And here I'm going to go litter space again with another spent stage. All throughout my code I have this little check that automatically stages when the fuel runs out. The complex check that does asparagus staging, that only exists in the Ascent script, because that's a lot of code. But just saying it stage until you have some fuel again, that's a simple one-liner, and I've got it all over my scripts. So that any point I'm at like this, where I'm about to run out of fuel in the middle of doing a burn, it'll go ahead and stage whenever it needs to. So at any moment now, you should see this run out. There it goes, and it's staged, and then it stopped burning. Now, the reason it stopped burning is because when I stage in the middle of the capture, it rechecks the maximum thrust to detect whether or not I'm still should be burning as early as I am. It noticed my new engines in my new stage are much more powerful than the ones I was using before, and therefore it needs to wait a little bit longer so I can straddle the periapsis with my burn, given that my burn will now take less time than it was going to have taken before. So it's smart enough to turn the engines off and wait again a little bit. And you'll notice it's saying that now that it's... There it goes. I was waiting for 28 seconds before periapsis with my new, better engines. These are the engines that are made for landing around the retros. Okay, so... sorry about the cough there. So now I'm going to burn till circularize, and this is one of those places where previously I wouldn't have bothered circularizing. I would have just gotten it the elliptical and captured it, it would have been good enough. But the reason I circularize everywhere is, in this case, because I wanted the ability to pick my landing site. I didn't want it to have to land at the place where the periapsis is, which is what it would have to do if I still have it highly elliptical. I want to be able to tell it, okay, you can start running the landing script now when I tell it to, so that I try to come down somewhere vaguely in the daylight. Again, it's not necessary to land in the daylight, other than for the purpose of, being able to see it on the video. I wrote this part of the script before I realized that there's a new feature that you can use to have your solar panels tell you whether or not you're in the daylight. I didn't know that existed when I made this. So future versions of this, I might go ahead and have that drive when to do the landing. There we go, now it's actually doing a thing. Have that burn a little too early. Anyway, it lowered the periapsis a bit to really commit itself to the idea of coming down in. And if you look at the bottom of the terminal window now, it says program will start when alt equals 40K. Now, you should be able to read the altitude on the top of the screen, but I think it might be getting cut off in the video. I'm not sure. I'll see when I actually post it. But when that altitude gets down to 40K, the program will actually do a thing. Oh, there we go. So it started up. Thrust a little bit more again to get itself down low. If you look at the terminal window, it's the same descent script I've always had in the past, but I've taken out some of the graphical characters around the edge, simply because I'm running into the 10K limit with it, and printing out all that extra spaces seemed like a pointless waste of characters. So if you read that, what that says up there, it's showing you my above ground level altitude, the altitude of the periapsis of my orbit. Now that says 82,064 meters. That's not really correct. What that really is the altitude of the highest mountain on Duna, which is in my database files. What that is saying is that because I can't see ahead of the craft in the script, and I don't know if there's a mountain coming up or something, what I do is take a worst case scenario and say the worst case scenario is that I'm going to intersect the ground at the height of the highest known mountain, which is that 82,000 number. And the reason that's important is that it's calculating what the terminal velocity is going to be at that altitude. You look there, it says term vel at P. That's terminal velocity at periapsis. And it knows that theoretically, worst case scenario, that's the thinnest air I might be landing in. And so it uses that to aerial brake perhaps a little bit, but it can't really do it very much because it can't trust it on Duna. On Duna, there's an enormous difference in air pressure between the highest mountain and the lowest valley. But pretty soon it'll stop waiting when it gets pretty low. Oh, there we go. It stopped trying to rely on the air resistance because it was, I think I have it set to when I am 4/3 of the terminal velocity, which should be about 700 or so in this case. 4/3 of what the terminal velocity at periapsis would be. Again, I call your attention to the splotchiness of the terrain. It doesn't really look like that when I'm playing the game. That's because my video compression is set really high. And there's no way I'm going to go and play this whole mission through again just to record the video again. I'm sticking with it. Bring all that fuel down into those gravity wells and back up. And I can't dock because docking isn't really implemented very well yet. Well, actually, docking works. What you can't do is use the RCS thrusters to translate. Here it goes. Here it goes. Come on. Don't hit the ground. Please don't hit the ground. There we go. Suicide burn. You can see it. Headlights turned on and the ground is very close. Now this bit here I have to explain. Notice it popped up. It got paranoid and panicked when it got really close and had the suicide burn toward the ground. And it popped up instead of drifting upward too much. Now the reason that happens is, again, because of the slowness of the execution that was caused by having video recorder software on. If it's only running iterations once every 2 seconds or so of my loop, then, and it needs to burn at full throttle, but it only needs to burn at full throttle for 1 second, the best it can possibly do is to burn at full throttle for 2 seconds. And then that's too much. It can't burn at half throttle for 2 seconds because that would take too long and it'd actually hit the ground. It really does need to burn at full strength. It just needs to burn at full strength for only 1 second, which is an impossible thing for the code to do if it takes 2 seconds to run each iteration of the loop, which it was doing because of, well, it's a pretty big loop, and I've got this incredibly delayed system. I guess if I do this in the future, I might go ahead and clear off all the disk space I would need and try to record it as raw frames first and encode it later. But I really didn't want to do that because I'd have to clear off quite a hefty amount of drive space to do that. So even though it kind of inefficiently popped up in the air there, it is coming back down to a landing. It's trying to maintain a speed of about 4 meters per second down, which would be a nice gentle landing that wouldn't eat up too much fuel if I was doing it from the intended height of 100 meters up. But I was doing it from a height of 300 meters up, so it's going to use a bit more fuel. But this mission was designed to have quite a hefty margin of extra fuel, so that's okay. And there it comes. There it comes. Big screenshot of the landing. And landed. Now, as this script ends, you're going to see something happen that I don't understand. If you look at the terminal window. Yep, flagrant error on line 0. A flagrant error is a way in KOS of saying that somewhere internally in KOS there was a C# exception that they didn't catch. And I've looked at the debug log that comes up when that occurs, and what it says is that some object has a null pointer, but it doesn't tell me which one, because that doesn't help at all. And weirdly enough, it only happens when I land with this script on Duna. It doesn't happen when I land anywhere else. It's only Duna. So it might have something to do with the atmospheric calculations, I don't know. But the other weird thing is it only occurs after the script is done. The actual descending script is over, and it gives me this afterward. I don't quite understand that. So what I'm going to do here is have my little Kerbals at home talk to the remote craft and try to get it to reboot from where it left off. So I imagine that they're back in Space Center going, quick, something went wrong in the craft. Let's try and talk to it over the radio and see if we can work out what happened. So one thing they're doing is they're going to ask it to tell me what programs are on your drive. And I'm using the sim radio delay for that. And it comes back and says, I'll tell you, but it'll take a few seconds. So I time warp through the radio delay here. And this is all perfectly legal according to the challenge, because while I'm landed like this is one of the times that I'm allowed to take the time to type commands manually. In fact, the challenge rules don't even require me to use the sim radio delay. That's something I added because I thought it was kind of a cool way to do it. So I see that it failed to actually delete the files at the end, so I will manually tell it to run the program that does that, which is called unload descend, which is already on it, but it just didn't run it. And oops, I typed that wrong. I'm going to have to go back in. There we go. And again, that itself will also now take a long radio delay. I kind of like this sim radio delay. It really makes this idea work. So, after a slow delay, we get the craft to unload its code, which is the next thing that the normal script would have done. Now I'm ready to start it up where I left off. I'm ready to continue from the challenge mission from the next spot. The challenge mission is actually being run from the home base and being sent out, so I shouldn't sim radio delay it. That's actually a mistake. I remember the mistake right here. Okay, so challenge mission 2, and I give it the step number. Let's see, 0 was taken off from Kerbin, 1 was escaping from it, 2 was transferring to Duna, 3 was getting captured, 4 was landing on Duna, so 5 is the next step. And 5, by the way, was turning action group 2 on, which is how I capture some science pod data. Again, science pod data has nothing to do with the actual challenge, but I thought it, story-wise made sense to have challenge pod data, or to have science pod data. So when this delay finishes, you'll end up getting little science windows popping. And I already asked whether it's acceptable to, click OK to the dialogues as one kind of input you're allowed to do, because there's no way to interface with these dialogues and get them to go away off the screen other than doing that. Just clicking the OK button to keep it. There we go. So we've landed and we've taken some different instrument scans, and now it's time to take off. I used the video editor to skip through some, fast forward through some boring footage of waiting for the radio delay. Here we go. Here's our countdown. 4, 3, 2, 1, and 0. Hello? Slow script again. Okay. Now, instead of leaving the bit behind, I decided to design this to go ahead and use that fuel in case I need it. So I lift off with the lander, or with the bottom part, knowing that I'm going to run out of that fuel fairly quickly. But it just gets me up out of there. And this is using the exact same ascent script that I used on Kerbin. It's the same script, just different parameters. Although I did choose 80 kilometers again, even though Duna is much smaller and I could have had a closer in final orbit. The reason I didn't have a closer in final orbit is because earlier, remember how I talked about how the time warp is kind of annoying around Duna. It doesn't let you time warp unless you're higher up. So I deliberately chose to go to a higher up orbit, even though it's a little inefficient, just so that it would allow me to run time warp faster than just like 10x. So they're running the same thing, only now, of course, the profile and speed is much lower because it's Duna, so I'm not going to be as fast when I get up to 80k as I would have on Kerbin. There it stops, drifts up. It's not going to do anything until it gets to periapsis, and then it'll circularize from there. And you can see from how tall that parabola is, just how inefficient of a takeoff this actually is. And this is the final stage of the craft that I'll be taking all the way back home, by the way. It's got one LVN nuclear engine and some fuel pods to run it. And that's everything to get to Ike, take off from Ike, get back to Kerbin. This is the final stage. Everything is done with this piece. And it's still a fairly significantly large thing. And the reason it's significantly large really just has to do with the fact that the LV-N nuclear engine is kind of tall, and it's hard to design a lander around it without the lander itself ending up being particularly bulky as a result. You'll notice I have those struts that come down to where the landing gear are. Or, I'm sorry, landing legs. I guess landing gear is for airplane wheels. It starts to circularize. It'll stop when I get closer to periapsis and apoapsis. There we go. Take that screenshot I need for the proof. Okay, the next program is called Match Inc. You tell it a target you'd like to match inclinations with, and it will try to burn so that you are now in the same plane as that target, same orbital plane. And once that gets up and going, I'm going to talk you through how that part works. Okay, if you go to the map, it selects my target, which I chose to be Ike. It notices that I have an inclination difference of 2.14 degrees, which isn't really a whole lot. I probably don't actually need to worry about inclination here, but just to demonstrate how it works. It doesn't use the targeting of Duna, by the way. It's just doing that so we can watch and see the little lines on the screen. It's not using those little lines. It can't even read them, actually. So if I look at my target's position from the parent and its velocity vector, and my target being Ike in this case, and I cross product those two together, I will get the normal to the plane of its orbit. I can do the same thing for myself. My current velocity and my position from the center of my body, I cross product those two vectors together, and I will get a normal vector to my plane. So I now have a normal vector to my plane and a normal vector to the target plane. If I compare the angle between those two vectors, that's the angle of inclination between our planes. And of course, as I was talking about before, you can always get the angle between two vectors by using the dot product of... In this case, I don't actually go all the way to getting the angle, I just get the cosine of the angle, and that's actually good enough for my needs. What I'm looking for is to burn to get rid of that angle. Well, the question is, where do I burn? Where's the descending node and the ascending node, the places where our planes intersect, which on this screen is shown with a little dotted white line. But how does my script find that out? And the answer to that is I can use the two normal vectors to do it. If I cross product my normal vector and my target's normal vector with each other, the vector that I get as a result of that will be aimed exactly parallel to the line of our intersecting planes. So that little white line you see there, a vector pointing in exactly that direction will be the result of cross-producting my normal with my target's normal. So all I have to do is wait until my up direction vector happens to match that direction vector, which I'm guaranteed will happen at some point in my orbit because I'll be automatic. So the point where those match each other, which use dot product defined, is the point where I should burn. And that's the point of all the text you see in the terminal over there at the bottom. It's saying cosine vis up is the cosine of the normal of that white line vector versus my up vector. I should have that hit 1.0 or negative 1.0, depending on which side of this I'm on when I'm there. Now, my semi-major axis and my orbit's eccentricity are used to calculate my true anomaly down there at the bottom. True anomaly is nothing more than the angle that you are from your own periapsis in your orbit. So, like, for example, a true anomaly of 180 means that you're at your apoapsis. A true anomaly of say 90 means that you're exactly halfway between your apoapsis and periapsis. Now, the reason for calculating that is to figure out which of the two nodes I'm at. Am I at which of the two nodes, whether I'm at the one that's closer to the apoapsis or the one that's closer to the periapsis? If my true anomaly is less than 90 degrees, I'm closer to my periapsis than my apoapsis, and I don't want to use that node. I want to use the one on the other side that's at a higher altitude because that's more efficient. So I use the true anomaly to work out if I'm at the one that's at the higher or the lower altitude. In this particular example, I'm going to be at the high altitude one first, so it'll just use that. Although, if I started on the other side, it would skip past it, say, oh, I'm not using this one, I'm going to the other side. Now, one weird thing I haven't quite worked out is that, according to the GUI screen, the place where I should do my burn doesn't match where my code says, but my code is really close. It's only off by a few degrees. I'm not quite sure what's causing that yet. Notice that I've got myself aimed anti-normal there. And the script is doing that automatically, of course. And that should kick in soon. Soon. Come on. You can do it. You notice it's going a little too late before it does it. Come on. When on earth are you going to start burning? Come on. There we go. So it's off by a bit as to when. I'm not really sure what's causing that. But it still gets me a nicer burn. And now I'm at 0.2 degrees of deflection rather than 2 degrees of deflection. So it kind of works, but I've still got to work out why that isn't exact. I'm not sure where that error is coming from. But now here I am, matched with my inclination, and now the next thing that the code will do is try to transfer from Duna up to Ike to land on Ike. Okay, so it's running the exact same software you saw it run before. And it's trying to find a working delta V. I'm not sure why the first guess is so incredibly low. It seems weird. I'm not sure what's causing that to happen. But at any rate, the algorithm works, even though it's starting at such a weird first guess. Found a hit, stopped at the hit, and now it's saying to start the maneuver there. Pretty close to where I actually am right now. When will it start the maneuver? Oh, I see. It's saying that I have to go an entire once around the planet first. Come on. Very soon now. Okay, here we go. It starts. And this terminal screen should look quite familiar. It's the same thing that was used to get from my orbit up to Duna in the first place. In case you're wondering if you can hear that in the background, yes, I was in fact listening to Sven Julie, and they had a Commander Cody short. Yes, that's exactly what I was having in the background when I did this. I'm not embarrassed to say it. Okay, I'm a little embarrassed to say it. And I was trying to find the point that's halfway to the burn time. It's not actually physically halfway in distance, it's half of the time that it takes to get to the burn. And that there will do the normal correction, which in this case, it really doesn't need to do very much because I'm already pretty close to spot on. The normal correction is sort of no real reason to bother, but the step is there in the code just in case something goes wonky and there is a reason to need to. So here it goes. And it burns. Come on, it burns! Oh. Come on. Burn, 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 burn. There, now it's burning, and it stopped. Again, it's the wiggly number problem. I really wish I had a solution to the wiggly number problem. I'm not quite sure how to deal with that. So what it's about to do here is rerun the capture script, which is the same thing you saw me using to do the Duna capture, only I was going to do it for Ike. So it's going to try and get the periapsis a bit closer. Let's see it burn in a moment. There we go. I told it I would like to try to get to 15 kilometers periapsis. Pretty close because it's a little moon. And there it goes, and it brings the throttle way down as it gets close so it can be nice and precise about it. There it is. Now it was trying to burn, in this case, anti-normal, trying to correct the orbit so it's more equatorial, although in this case you can see it's almost exactly equatorial anyway. So it's not going to have to do very much to fix that. Yep, there, poof, it was already done. And now it's going to see if it needs to adjust the periapsis again because of the anti-normal burn may have moved it, but it didn't. So it'll hit for just a moment and then realize that it's not any work to do. Interesting effect you can see on the screen there. That's a weird video effect. I mean, the moon looked like part of the sun for some reason. Okay, waiting until 17 seconds before periapsis for the capture burn, so just time warp to that. Time warpy. I often find that I wish I had a time warp setting like halfway between two of the other settings. Like the one from 100 to 1000, I sometimes wish I had like a 500 in the middle of that. Alright, burning. And again, I decided to go ahead and tell it to make this capture into a circularized capture. Again, not strictly necessary, but just did it for the heck of it. And the algorithm that it uses for this is to keep burning until it notices that it has gotten closer to apoapsis than the periapsis. And if you start burning at the periapsis and the apoapsis starts to rotate around towards you, that point where you've hit exactly the 180 point between them is the point where burning any further won't help. Just so you know, that's the algorithm I'm using. Here comes the descent again, same program as I used on Duna, but with just slightly different parameters. It's very hard to see what's happening here, because, again, I ended up landing slightly on the dark side of dawn here. And Dawn is really furious. She doesn't like that. should be having my lights turn on very soon. Once they do, that's when you know I'm near the ground. Oh, there we go. Lights turn on. Yeesh. It's a slightly better landing than on Duna. This really looked like it was going to tip over. I got worried. I found some somewhat flat land, but it wasn't as flat as I probably would have liked. That's really dangerously close to having tipped over. But you'll notice this time, after the descent script, it didn't crash like it did on Duna. No idea what the difference is. Here I'm just playing with the camera a little bit because I was trying to get a nice screenshot with the floor and Duna. There we go. Just getting a screenshot of the map view of the landed thing as well. Instead of radioing the sciencey data back, I'm actually trying to bring it back in the actual line. So I've taken some sciencey things off of Duna and some sciencey things off of Ike. I think I have a materials bay, a goo container, a barometer pressure, a seismometer, and a thermometer. And I have 2 of each of those on this craft. One set of them activated by AG2 and the other one activated by AG3. Okay. 7, 6, 5, 4, 3, 2, 1. This is a fun takeoff, by the way. Because it goes sideways almost immediately on the takeoff. Kind of frightened me at first when I saw that. But again, that's because it knows there's no atmosphere, and it's actually more efficient to do a low takeoff. So when there's no atmosphere, it just bends over right away. I was concerned that I might hit a mountain on the way into orbit, but luckily it didn't. It's trying to circularize. You've seen this before. So what speed does it think it will need to get up 358? It's already at 350 something, so it should be... Oh, there, it stopped. Okay. So now this is the escape program again, same one as I used before, to get off of Kerbal. Only now I'm trying to use it to get off of Ike. And in this case, the parent that it's looking at is now Duna rather than the sun. And it's trying to wait until it's pointed directly away from or toward Duna. In this case, it's waiting until it's pointing directly toward because it's trying to do a retrograde escape. So I'm trying to find the exact point where I'm on this side of the moon here. And I know this isn't 100% the most efficient place to do the burn, but it is the easiest to calculate. to try to figure out that I'm on the front side of the moon's orbit because I'm pointed at Duna. I originally tried doing it by looking at the velocity of the body that I'm orbiting, but it turns out that doesn't work, because it gives you that velocity in a frame of reference centered on that body itself, so it's always 0. Okay, there's the burn. And if you back up here to the map, I do back up to the map at some point, don't I? Map? Okay. You see I'm elongating the ellipse in Ike's retrograde direction. And this is the part where the inability to see the sphere of influence radius is really going to start to make this code look like it's doing something incredibly stupid. It didn't know that it was already out of the moon. It's making its calculation based on the laws of physics and based on escape velocity, which means it has to go a lot faster to get away than the actual sphere of influence would require it to. Which meant it slowed itself down too much and is now in a collision course with Duna. But I knew that was going to happen because I had run this before, so I had it set up so that the very next piece of software that runs, without any intervention from me at all, is it jumps into another version of the capture script, only this one will do the opposite because it'll notice I'm on an impact path and it'll raise the impact path. There we go. And you'll see that what it's actually doing is doing the opposite of what capture normally does. In this case, it's raising the periapsis until it's no longer buried in the surface of the planet. And it gets up to the desired, I think I set it to 70, I'm not sure. Yeah, it's 70. So the capture script's ability to adjust your periapsis to a point near where you want it to be is sort of universal. It works regardless of whether you're trying to go in tighter or out higher. In this case, I'm using its functional ability to go out higher to prevent it from crashing into the Duna. But the next part of the capture script is to try to make sure that I'm captured and I'm not going to escape. And you'll notice that it's thinking I'm going to escape. It doesn't realize I'm captured. And there's a reason it's doing this, and that's because I don't know the sphere of influence radiuses, so even though this is a captured orbit, I can't presume that it's smaller than the sphere of influence. And so I think I remember rightly, I have it set to something like my velocity has to be 80% of escape velocity for me to consider it captured. I think is the threshold I use. It might have been 70%. I don't remember at the point when I put in the code. But at a future version, when I start to be able to query the SOI radiuses, those will, or radii, those things will stop being so silly. So why did I fall back into Duna? The reason was because I'm going to try to escape from the system to try to get back to Kerbin now. And it's actually more efficient to do it by falling into Duna and then coming back out than it is to try to do it from the height of Ike. Now, another thing that I might do in a future version is make it smart enough to know to wait until the right time to try to leave Duna to get to Kerbin, and wait for the right time to try to leave Kerbin to get to Duna. Basically, wait until the planets are already in the right position before I even take off in the first place, which is, how real space programs do it. They don't put a probe into space, into orbit around the sun, and then wait until it finally gets to the right place to take another burn from there. No, they just wait and don't launch it from Earth at all until the right moment. And right now my software is not doing that. It will launch at any moment that you feel like, and then while it's out in interstellar or interplanetary orbit, it'll then wait around for the right moment. Yeah, I know, it's not perfect. It's crude. This is what I could get accomplished with what I currently have in both my math toolbox and KOS's toolbox. So it should be able to just skip ahead here. Oh, time warp because I'm near Duna, right? Come on, let me go faster. That is so annoying at times. There. So it skips ahead until I am outside of Duna's sphere of influence. Now, this is another interesting quirk, and this is a quirk of KSP itself, which is that I left Duna, and there I am back in its sphere of influence again. And I left it, and I'm back in its sphere of influence again. And the reason it's doing that is because the sphere of influence is smaller than the laws of physics would actually say has me escaping. And so what happens is if I escape in the retrograde direction, I end up catching up to the planet again and getting back in its sphere of influence. You have to get quite a ways away from it before the game stops doing that. Okay, so I think it's the point where it won't do that anymore. And now it's time to find my way back to Kerbin. And if I remember correctly, at this point, the transfer script did have to do quite a bit of iterative searching. All the other times I've managed to be lucky enough to get it to find it on the first go. And if I remember rightly, on this particular occasion is when it was close but not quite, and it had to think for a while to find it. I think you'll see that coming up in a moment here. Load the trans, run the transfer back to Kerbin. Yeah, okay. So it picks its first guess node, or is it guessing node? There it is. So it's saying that I'm going to delta V down from there, and you'll notice the little chevrons appearing saying, that I'm close, but it's not quite right. And it's going to have to guess forward and backward in time a lot to get to the right spot. So what I'm probably going to do is, again, take an opportunity here to speed the video up so that you can kind of watch it happening, but it'll happen a lot faster than it really happened in the real world. No, that's not a match. It almost was. It's going to have to go one more iteration in that direction before it finds a hit. And now it's trying an iteration in the opposite direction, which, again, if I could read those chevrons, I would already know that that wasn't going to work, and I could cut that part of the search out, but I can't read them. There we go. Ah, found one. Not the best hit, but, it works. So now, time warp until it hits that point. This is one of those places where I did, in fact, have a bit of code that automatically knocks your time warp down to 1. I do it at the right spot to get you down to about 3 hours prior to your burn. I can't get it any closer than that because the time that it takes to get from high time warp to no time warp isn't quite deterministic, it seems. It sometimes takes slightly longer, sometimes can do it very quickly, and so I can't try to get it more precise than 3 hours ahead of the burn. So it'll stop, if you time warp up to one of these burns, it'll stop you 3 hours before, and then you'll have to manually time warp a little bit more to get up to the actual burn, and then it won't stop you in that extra little bit you have to do. But it does keep you from, zipping past it at like 100,000 times fast speed. So here I am, it's the same exact code, even though I'm going in the opposite direction and falling in, the same code works. And again, this is that same problem where if you can see there how much the periapsis was wiggling, and it's that same problem because that number wiggles all over the place. My script goes, oh, hey, look, I've hit a minimum, when, it hasn't. And I even put code in there that, like I said, takes a sample takes 4 different samples and averages them. And that itself isn't even enough to seem to make it work. I think what I have to do is take a bunch of samples and get the minimum value that I'm getting within those samples, get the maximum value I'm getting within those samples, and figure out the minimum of that range and use that as the actual value rather than averaging a couple of samples. And maybe that'll be more reliable. I don't know. But the point is that KOS script is slow, so if I take a bunch of samples of the periapsis, then I'm not causing it to not be able to detect quickly enough to stop the engines, and I'm slowing down the rate at which it's checking. So it's kind of a thorny problem. I'm not sure what to do. Now I finally understand what sports commentators feel like when, when they have to fill all this dead air with talk and they just don't have anything to say, so the talk starts to sound particularly inane. At least I'm not giving you statistics that are about the record of my play in past games of Kerbal Space Program or something like that. Nothing can save sports commentators from the fact that they are inherently boring, but I can kind of have a little sympathy for why they sound so boring, because now that I've been having to do this in this long video, I understand how hard it is to constantly have to talk and come up with something to say when you've got nothing. Come on, get closer. Get closer. Come on, get closer. Closer. My neatness is to the normalization burn, which it's probably also, again, because of the wiggly number problem, it's not going to do that very well. And I know you probably don't believe this, but rest assured, the wiggly number problem was less of a problem when I wasn't running the software that does the video recording. It's somehow changing the timing of the CPU so that it doesn't run as quickly, somehow caused this to make the wiggly numbers worse. And again, I'm not sure what's doing that. It is very interesting, but I'm not sure the solution. Now here it's doing a little bit better. It actually is, in fact, continuing the burn a bit longer. It can't correct for the fact that I didn't burn long enough earlier, so it'll only help a little bit. But if you notice, the periapsis number there is, getting better as I burn in the anti-normal direction here. Okay, so you can see that's a particularly bad pass. I'm really far away from Kerbin there. But it is still going to try and correct it. It actually does barely have enough to do it. And there we go. And it comes in. Done. And in that time, I told the capture program that I wouldn't mind diving into the atmosphere, hence why the periapsis is as low as it is. And the code's not perfect on that. It's not actually checking what is the altitude at which I would have enough drag to come in. What it's basically saying is reduce the altitude to the height of the highest mountain that is known to exist on the planet. That's why my periapsis is about 7,000. It should actually be a little higher. If I had the deadly re-entry mod, this probably would not do. I would probably be coming into the atmosphere a bit too hot. But for a stock game, it works. And then my descent back onto Kerbin, I decided that I would design it so that it's pure parachutes. That wasn't so much because I can't land on Kerbin. I could have made it land on Kerbin. The reason I chose not to was because I wanted to make sure that even if I had only a tiny smidgen of fuel left, that I could still operate without the fuel. So it's a parachute-only descent where my code doesn't have much work to do, purely because that way I don't need an enormous amount of fuel when I get back. As long as I barely had enough to get into the capture position, that's good enough. And yet again, I seem to have expertly managed to set it up so I'm going to land at night in the dark, which, is just great for making videos. Sorry about that. Just the way it happened to work out. Actually, not just the way it happened to work out. It's now I think about it, it's sort of deterministic that it would work out that way. Given that the code won't burn to get it all lined up nicely, and yeah, it's automatically going to come around the backside of the planet from the sun the way the code is working now. So it actually would do this every time. Now that I think about it. But right now the code is just operating on dumb. I turned the chutes on. I'm gonna wait for them to deploy. I don't have any work to do anymore at this point. Whatever happens, happens. The code. I mean, you could literally turn the computer off at this. Turn the KOS computer off, and it wouldn't make any difference. It already told the chutes to deploy. And I think this is over the middle of the ocean, so it's going to be a splashdown landing, which is always a little touchy because I've noticed the way the physics engine works, it's actually easier to get a craft to land successfully on the land than it is on the water. For some bizarre reason, impacting the water tends to actually create more of an impact than impacting the land. Seems a bit weird to me, but it does seem to be the case. Like if I'm descending at, say, 8 meters a second into the ground, I'll survive the impact. If I hit the water at 8 meters per second, I sometimes don't. Which I thought was funny, because I thought, part of the reason that the Apollo programs brought everyone back into the ocean was because the cushion of the water will help a little bit. Speaking of cushion of the water, that sound effect was out of sync. You heard it splash down already. Weird. There. And that's the actual splashdown. So my sound on the video earlier was a little out of sync. Okay, so there it is, successfully splashed. And again, the Kerbal engineering at making everything float is pretty cool. Anything you make it float, doesn't matter what it is. In fact, this is floating on the landing legs and the girders, and not on the actual tanks. So, just to technically complete the mission, I went into the home space station. I went to the Kerbal Space port and recovered the science from the mission, just to, even though again that's not required, it doesn't matter. It's just so that I can look like I did a thing. Kerbal Space Center. Space Center. And that was worth 675 sciencey points for that mission. It would have been more, but I'd already done some of the things that were on it earlier. Okay, so that finishes it. That's my entry. That's my second entry into that challenge contest. So let me know what you think.